Okay. Hello, everybody, and welcome to the first meeting of the Device Management Interface Brigade. As you can see, we have a rolling agenda, which many of you will be used to with other brigades at ONF. Starts with the meeting of today, and it contains the agenda. And I encourage everybody to add to this agenda any topic that they would like to discuss in upcoming meetings. Here you can see some of the important elements that we have. We have a Slack channel. We have that I encourage you to join. We have a Jira board where all the tickets pertaining to the brigade will be put in. We currently don't have any repository for the brigade itself. We'll discuss today some of that to upstream some of the contributions. The video recordings will be in this playlist, and an important link, and you will see why today, is RFC 8348. So just to give people a little bit of background, this discussion stems from a presentation and a set of, again, elements that were discussed at the Volta meeting at the end of April, so almost a month ago. In there, we discussed how to better manage devices outside of the scope of Volta, meaning not on the control side, but how to do measurements, events, and software update that are not really pertaining within the Volta stack. So the idea of this brigade is to define and contribute the interface for the device management components. We will have to define the operation relationships with Volta, meaning how do Volta and this component interact, if any, for objects that are common to both. For example, an operation like device reboot, or device IDs because both Volta and the device management components will interact against the same device. Scope of this brigade is also putting in some testing in place to make sure that these operations that we want to do are actually tested, very similar to our nightly regression tests that we do for provisioning subscribers, making sure ports are up and all of that. We will put in some of that in here. We have to discuss the priorities of the different features based on the operator requirements. Define the set of parameters that need to be implemented first and have priority, and more on that later. But let me also be clear that this brigade has no scope. It's not in the scope of this brigade or the people discussing on the interface. They won't build a device management component. That will be a vendor/community responsibility, which implementation is out of scope of this brigade. The development of those device management components that implement the interface that this brigade decides, it's the proper one, will not contain any ONF resources, given the already very thin group of people that is stretched upon the different tasks within Volta and SIBA. Obviously, if any piece of code that is developed by the community, by the vendors, is contributed to the ONF code base, it can be brought up here, and we can create a repository for it, and it will be more than welcome to be contributed to the ONF code bases under the open core repos. But ONF will not devote any resources to actually do development of those device management components. The same, for now, goes for the device management stack, meaning that whatever sits northbound as a device management component will be built into NEM, and that is, again, out of scope of this brigade. We will provide the tests to make sure that the interface we require out of those device management components is present and works, but we will not build any of the northbound objects rather than the tests. So before I go forward, any questions here? Okay. If not, I'm always more than welcome to accept any questions. I forgot to mention, I am Andrea Campanella from the Open Networking Foundation. Many of you know me, so that's why I didn't do it. But for those who don't know me, I'm working in the Volta SIBA team based in Europe. Anytime you can shoot me an email at andrea@opennetworking.org. That's written wrong. Anytime for any questions, just shoot me an email. Okay. Something else that before we go forward and that I have to make sure everybody's on the same page on is the timing and relationship of the artifacts that this brigade produces with the Volta artifacts. Whatever this brigade produces will not be included as part of any Volta release, meaning that a Volta release will be not held up by anything we do. Whatever this interface is and whatever in the future components that implement that interface will have their own release cycle, will have their own set of discussions and Docker images and everything, but those will be unrelated to Volta 2.4 or any release of Volta. Just to take an example, the release of Volta 2.4 will be at the end of June, will not be predicated upon anything this brigade outputs, meaning that it will not be held if we don't come up with a 1.0 of our interface. The two will be separated, and just because it's this is something that it goes hand in hand with Volta, but it's a completely separate stack. It's device management stack. While Volta does a lot of the control, we will do different things. So we don't want to marry these two elements. Obviously, as I wrote in the agenda, the two releases of device management APIs and a given Volta, example 2.4, can be advertised to work together as part of a bigger solution to manage the access, fixed access. But again, they're not married because this interacts with other components such as NEM. So we will have our own release cycle independent of Volta. Again, before I go forward, any questions? Okay, I'm either terribly clear or nobody's really listening to me, which I fear both.
We can hear you, and you now have a Jira dashboard for that epic.
Oh, thanks, Zach. Appreciate it. Do you mind putting in the, oh. Well,
already there.
Ah, you precede me. You read my mind. Thanks a lot. Yeah, so anybody wants to pick and see immediately, I can actually bring this up. Okay, I will need to log in. I don't usually use Chrome. I'll make sure to log in next time. Okay, any other questions? Okay, then if not, I'd like to pass the ball in the hands of Amit Ghosh from Matrices, who is going to present a set of protobuf files that are Matrices DT's initial proposal for the device management interface. Just to be clear, I think Amit will talk a lot more about this, but because I said that it would be important, these are based on the RFC 8348 from IETF. It's well-known RFC. It's a very simple data model, in Yang based. And this is where we start. Having said that, I'll let Amit take on from here. Amit, you can go ahead and share screen whenever you want and take it from now from there.
Thanks, Andrea. Yeah. Hello, everyone. Let me start sharing my screen. So, can everyone see my screen?
Yeah, we can.
Yeah. So, as Andrea started off by saying that the model that we are working towards or proposing is based on the RFC 8348, right? So, we'll start looking into that. So what we have done till now, let me just try to walk you through that. So the entire device management, we have broken it down into 4 specific areas. One is management of the physical hardware, right? So, and that is captured in this file called HW management service.proto, which has some RPCs. We will go through those. And then we have events management from that device, management of events from the device, management of matrices from that device, and management of the software images on the device. So specifically 4 areas that or 4 aspects of the device that we are trying to manage. So if we start with the hardware management, we have defined 4 RPCs. So basically you start off with saying that, okay, we want to manage a specific device or a piece of hardware. And a hardware, the way we are defining it is a root component, right? And what a component is specifically defined by the RFC. So if I were to go to the RFC, you see this is how the hardware is modeled. So the hardware is basically a list of components, and each component has a certain number of attributes. And this is exactly what we have taken and modeled it. So we have all the same attributes out here. So what we are saying is that each hardware will have a root component, right? And this will have all the other components as children. So I won't go into the details or the lower level attributes or the nested structures inside that, right? I think anybody can look up through that. And once we put this up for review, you could always give in your comments on that. So right now, the idea would be to go at a very high level to see what the RPCs are and what we could achieve using this. And feel free to please interrupt me at any point of time if you have any questions. So coming back to, what we could manage, right? So we said that, okay, start managing a device and we provide the hardware, so which effectively would contain the IP address. And if you want to assign a specific UUID for the device, right, that could contain that. And after we are done with this RPC and say if everything returns successful, right, then you could get the physical inventory of the device, right? So which would return the complete tree of components that are inside the device. You could look into a specific hardware component, right? Or you could set certain attributes of a component. So as of today, if you look into it, so what you could set is, again, the attributes that are read-write. So that have been captured as what we call as the attributes of a component which can be modified. So as per the RFC, these are the only attributes that can be modified. But the one that we really see would be used more frequently or at least in the beginning, is the admin state. So if you want to enable or disable a particular component, this is what would be used. So any questions on this one, or do you want me to go through the nested structures as well?
Perhaps just one question on the admin state. So this is Holger from Adren.
Sure.
If you disable a device or some component here, and at the same time the Volta adapter is communicating with a device, how is this going to be handled?
Yeah, so I think we'll keep that question for a little later, because that's what
Okay.
Andrea also was saying, right? So I think we have to draw the line between this component and Volta and try to make sure that there is no overlap between what this component is managing and what Volta is managing. Else, it is going to be tricky and confusing as well. Right? If we have two parts to manage the same component or same aspects of a device, then it's going to be tricky. So the current thought is that from an implementation perspective, right, this component should do things which Volta can't do, or Volta is not doing as of today. Right, so Volta is not looking at things like fan, power supply, CPU, and things like that, right? And you could use this component to do it. But whatever is already implemented in Volta, for example, you could set the admin state of a device or a port through Volta. So continue to use that, and we don't exercise those APIs using this interface. So
yeah, I was more thinking about, okay, yeah. I think I got this, but I was more interested in what happens if you do something on the device management side which influences something on Volta. So if you disable a device where the Volta adapter is already connected to, for example, or if you would.
So let me comment a little bit on that. Disable is precisely an example that is pertaining to what Amit was saying. Disable can be done through Volta and will be the responsibility of Volta. We will not have the disable capability here of the whole device, nor of a single ONU, nor of a single PON port, because those elements are already present in Volta and are already done through the Volta stack. And thus, we won't need to do them here, precisely for the reason that we don't want two components setting different state for the same attribute. So whatever is done through Volta will be kept through Volta, unless the decision becomes to take it out from Volta and put it in here. But that, for now, is something that we don't plan to do. Does that answer your question?
Yep. Thanks.
Okay. So let's move on to the next service, which is events, right? So the events and matrices, the RPCs are pretty simple and similar. So we have only two RPCs, right? So you could ask the adapter or the device manager for the list of events that this specific piece of hardware can generate, right? So that basically get the supported list of events. And then you have another RPC through which you could configure the generation of those events. So you could turn them on or off, right? So what is a little interesting here to see is how do we define an event? So an event basically is defined as a metadata which says, okay, from which device it is generated, which component it is generated, which hardware component it is generated from, the name of the component, and event ID, right, which is basically a one of the values of an enum, right, which captures all the events that we have thought of now, and this has to be added, right? If we need more events. Yeah. So the event ID, the time at which the event was raised, and for certain events, if there are some threshold information, right, that is captured as well. So it's an optional element. And if there is any additional information which needs to be passed as a plain string. So that is how we define an event. And for each of the events, you have a configuration, which is like saying, is this event configured? Is a Boolean true or false? So if you set it to false, then the device manager is not supposed to generate these events. And if for certain events, there could be thresholds. So for those events, the thresholds could be configured as well.
So are these going to be only thresholds that are actually implemented on the device in the hardware?
So, so it's not necessary. So here we are talking about the interface to the device manager, right? So it is up to the device manager's implementation as to how it takes care of it. If it could program the thresholds onto the device, that's great. I think it makes it easier for it. But if not, it could implement it on its own.
Okay, I'm going to just renew my continual objection that thresholding, this type of analysis, is not part of what I want to say, our systems. Typically, you have another analysis system. Our system is to generate data, not necessarily evaluate or do analysis on that data. And this thresholding, particularly those that not implemented in the device, come dangerously close to saying we're going to start implementing more complex analysis. And I don't think that's in our scope.
So I think that is something that we could check with the vendors, right? If most of the devices support setting thresholds in the device itself, because in that case, I think it becomes, isn't the responsibility is not really in the implementation of the device manager. So things like temperature and specifically temperature, right? That is one of the things, or even yeah, and RX power, TX power, voltages, and things like that. So yeah, we could check that from the vendors, because if most of the devices do support that, then I guess we could keep that in.
Yeah, just I would hold off from doing any analysis or thresholding in the device manager interface. You know, I understand if the hardware device has it, or the hardware has it implemented in it, we may want to expose that, but in terms of the implementation, I wouldn't, the device manager implementation, I wouldn't put any analysis in that. All right, thank you.
I would agree with David. I think the idea would be to have this as a pass-through, meaning this API receives a request to configure a threshold. It passes it down to the device manager. It passes it down within the manager to the device, and that's it. And the device will generate the event up with that threshold. We're not gonna change thresholds based on events. I think that at least how I see it, it's a very pass-through component. It doesn't have a lot of intelligence. So let's make sure of that. But that would be my take.
So Andrea, it's Manuel. Hi everybody. Just to make sure I understand. So what you're saying is basically on the API that is the same result, right? But what you're looking for is southbound, then that the native manager, the device manager adapter would actually just pass through, but that is not up to the concern of the API in the first place, right? So whether the API was supported or not, where it actually is happening would be left up to the implementation. Am I right? So even if we say, of course, we all agree that the device manager adapter is not supposed to be the component that has the intelligence to do threshold crossing alerts or any of those closed loop analysis, still the implementation could do it sort of on the hardware if it can, and that doesn't matter then to the API if it supports it. Am I right, or did I miss it?
Completely. What I would say on top of that is that if a threshold is configured by the northbound, that has to be respected, meaning that there is no intelligence that changes it within the manager, the device manager. Meaning that, for example, I would see some devices having already a temperature threshold, a temperature cutoff threshold. That is hard coded because that's something fairly important. And I'm okay with the device manager reporting that to the northbound if asked. What I'm not okay is changing alarm threshold underneath the API, meaning that whatever was set through the API must be retrieved from the API and be the same.
So, I mean, I would go a step further and say, look, if a device has a hardware implemented threshold, then that is exposed through the API, both get and set. If any software defined thresholding should be done outside of this project. Software implemented threshold. So if, let's say a device didn't have a temperature threshold built into the hardware, then I wouldn't have the adapter or the device manager implement that. I would say, look, we will publish that information, and that is up to a data analysis system to manage thresholding and any alert further event based on that threshold.
Okay, so I think we are in alignment there. So as Andrea said, and as David, you're saying that if the hardware supports it, we pass it through to the hardware, but not have the device manager do the thresholding in software. Yeah, good mandate there. Okay. Anything else? Any other points on this event management? Since we could go to the matrices.
Sorry, just one general question. So all events are then going to Kafka, like
yes, that's a good point. So here what we have is an RPC mechanism. So and we are thinking of gRPC, right? This protocol should be used over gRPC. But the event that we are talking about here, yes, they are thought, the event and the matrices, they are thought to be submitted to the Kafka bus, right? And from where it would be consumed by northbound systems and dealt with for further processing.
Okay. And while you already mentioned gRPC, what is the reason for using gRPC as the transport and not, for example, Kafka, like it is done for the adapters?
So the current Volta core interface that it exposes is also gRPC. And I think even the Kafka that we are talking about between the adapters, I think we are contemplating in the community as to whether it would remain that way or we would go the gRPC way, right? So it's basically, I think, a question about, do we really need a bus architecture or a point-to-point architecture is good enough?
Yeah, can I interject on that? Thanks, Amit. That is exactly the point. So for many of these APIs, they are request API, return API, and even for the event API, what we will do is that the gRPC API will ask the device manager to list events, push out events, subscribe to events, whatever, and then they will be retrieved from the Kafka bus. In the case of event, the Kafka bus makes a lot of sense because you just post on it and somebody else reads from it. But in the case of a more mandatory API, such as set this value, get this value, do the software update, don't do the software update, or activate an image or things like that. In that case, the gRPC proves much better than posting something to Kafka with a topic and then having the other components read from Kafka with a topic. It also makes a much simpler implementation. You basically require one less element, which is the Kafka bus. Yeah, so, and it's also, I would say, faster because of the point-to-point and all of that. So that is the reasoning. And as Amit said, gRPC is and protobuf without Kafka is already ubiquitous in Volta itself. So that is the choice that we made, and we're sticking with it for these reasons.
So the
Okay.
the pipeline from event generated from device to an external system is the device generates an event in a native protocol that is picked up by a device manager adapter, translated into a protobuf, and published via streaming gRPC back to the device manager, at which point the device manager puts it on Kafka. Is that the pipeline we're talking about?
I think there is one more component there than what is actually needed. Meaning that what is the device manager can immediately push it out to Kafka. And there is no need of two components there. Basically, the device manager gets it from the device in whatever format, translates it to protobuf, and pushes it out to Kafka. That's it.
Okay, I thought there was an adapter between the device manager and the device.
No, really here, what we call the device manager is the adapter. There is really no higher element.
Okay.
We're not concerning ourselves with that. So really what we're focusing on here is that device manager adapter, which is, let's say, one for the Adtran with the netconf, one for Edgecore with Redfish, stuff like this. Okay?
Okay. All right. Thank you.
Okay. Thanks, Andrea. Thanks for the clarifications. So let's move on to the next section, which is matrices. Right. So again, here the RPCs are similar. So you have list matrices, which returns the set of matrices that can be gathered for a specific piece of hardware. Similarly, you could, as events, you could update the configuration for metrics. So here by configuration, again, it's enable, disable if you want to capture those matrices or not, and a poll interval at which to poll for the matrices. And we have one more RPC here, which is get a particular metric. So this is something that could be used to get instantaneous values. Right, so the other matrices are more to be used for periodic collection. So you could configure poll frequency, and the manager's job would be to go to the device at that frequency, collect it, and again convert it to protobuf format and dump it to the Kafka bus. So
is there any value to say, look, if you want to pull device metrics every 15 minutes, this API will give you the capability to pull the metrics, use cron, use something outside of this to call that API every 15 minutes. Now we've sort of got a scheduler built into the device manager now.
Sorry, David, I didn't get your question clearly.
So assuming, again, that this device, this periodic metric polling is not something implemented in hardware, i.e. you don't say hardware, send me metrics every 15 minutes. So assuming it is a top-down poll, why not say, look, the API will give you the capability to query the metrics. It is up to another system to say, query it every 15 minutes, rather than put a scheduler, a cron capability into the device manager?
Yeah, so what you're saying could be achieved by calling this get metric, which returns the instantaneous value at the point of time, right? Every 15 minutes.
Yes. So why would we put a scheduler into the device manager?
Yeah, so again, if the hardware itself can support it, that you give it the metrics that you want and ask it to report it every whatever periodic interval, and it does the collection and then reports the buckets, then it could use this API to have it much more easier and streamlined.
Okay, so if the hardware supports the bucketing on the hardware, okay,
Yeah.
expose it. But if the hardware, I guess, is there somewhere an API here that says, hey, give me some sort of capabilities around these metrics and even the thresholding, I guess, to say I need a descriptor to say, does this hardware support 15-minute buckets? Or are we expecting every hardware or every adapter to support the 15-minute polling or whatever it is? And if it's not implemented in the hardware, to have that adapter implement it?
Yeah, so so right now the thought is that if the hardware supports it, right, we could do it from the hardware itself. That is straightforward.
Mm-hmm.
Whether as you're questioning, right, whether we should build a scheduler, I think you are saying that we should not build a scheduler. I think that's open, right? As in, do we see a problem in building a scheduler in the device manager?
I wouldn't do it, but that's me.
David, what is the argument against?
Cron exists. Other systems exist that do this. Why are we building it into our system?
But
why not give the base capabilities, which is get the metrics, and then let other systems deal with things that they already deal with, whether that's cron for periodic polling, whether that's whatever, right? It's just trying to keep this as thin as possible in reality. Now, the problem we quickly run into is if one hardware supports a 15-minute poll cycle on the hardware and another doesn't, now
well,
you don't got a common interface anymore.
So as far as I know, take aside a little bit the white box stuff for a second. Even there, we can talk about some support for periodic reporting that it's existing. But any major hardware from basically any major software hardware vendor that sells it to you with some software on it does have the capability of periodic metrics reporting. So that is why I'm tending towards allowing this. And if the device does not support it, you could just return unsupported and just go through the get metric API. And that is where your cron job and other stuff gets it from, the northbound. But given the fact that I think many devices do support it, I would go for using it.
And that's fine. The question then becomes, is there a need for a capability query so that I have from an external source be able to say, do you support this, or is just call the method and handle the error, the unsupported error?
That's a valid point. I wrote it in our document. That is something that we can definitely discuss. I'm not against it. Actually, that's a pretty good idea. It could be in the initial handshake. It could be something in the hardware. I think that it's a well-worth proposal to make, and I'm not against it. Actually, I think it's good. It's a good to have capabilities of the device. What I would suggest is that we upload these proto as they are, and then we can build on top of them. So what I would do is, and I'll talk about it a little bit later, but I'm just going to bring it forward because it came up. We're going to start a repo. We're going to push a first patch with these set of protos. And what I would do is comments related to the existing code can go in, and things that we would like to have in the protos, we can have them as Jira stories, and we can look at putting them in, discussing them in future calls. Would that work?
Yeah, that's fine.
Perfect. Okay. In the interest of time, Amit, why don't you go forward?
Yeah, sure. So, yeah, so as we were talking about, the metric basically is defined by a metric ID. Similar to events, you have the set of enum of different matrices which could be collected from the hardware. A metadata which again identifies the device and the component which is generating the metric, and component sensor data. So this is something which we are reusing from the RFC 8348, where it captures the data from a component, right? So you have different things out there by which you could capture different types of data with different precisions and different scales and things like that. So we are reusing the same thing to capture the value of the metric. Yeah, and the rest of the things are pretty straightforward. So I'll just go to the next one, which is software management. So in the software management, what we have right now is 4 APIs or 4 RPCs. One is to get the version of the software that is currently available on the device. So it should return the version of the software both on the active and standby partitions. You have an RPC to download a specific image, an RPC to activate that image, and an RPC to revert to the standby image. So here what we are proposing is that the download can happen only on the standby partition. So one assumption that we are making, or one, let's not call it assumption, one, as in we are making it a little stricter for the moment, right? For the initial version of this API, saying that, okay, you could have only one version of an image on each of the partitions. We will not support for now having multiple versions of the image on each of the partitions. So when you download an image, you download that onto the standby partition. And then you can activate that image, right? If the activation is successful, then the partitions, the images get swapped, right? Basically the active gets marked as, the old active gets marked as standby, and the standby gets marked as active. And you have API to revert to the image on the standby. So this is something which the operator could want to use if he wants to go back to the previous software version. Now, how we are defining software, right? So here what you could see is that we are passing, so when you say the download image, right, we pass the image information on this API. Download image request, image information, and the image information basically contains the image version, which is the name of the image and the version, a script or the name of a script which knows how to install this image, the location where this image and the script are present, and checksum for this image. And then these are things which are returned as part of the RPCs as the return status. So when you ask for a download or an activation, right, so it returns the status of the image. So it has the current image state, and if there is a failure, what is the failure reason? So yeah, so this is basically what goes to the device manager. So a path where the image and a script which knows how to install that image are present along with the checksum, And from here, the device manager takes it on and works with the native APIs of the device, right, to push the image down to the device. Yeah, I went through that pretty fast. Expecting questions on this.
One question, did you think about a commit stage for images? I mean, currently not, so.
Yeah, so what we are saying is that the commit is something that depending on the type of device, right, it goes into the implementation of the device manager.
Yeah, but in order to allow a commit, you need another RPC, I think. So, I mean, currently you will, if you do an activate image, then you will like reboot the device comes up with a new software, and this is then already the committed software, right?
No, so the device comes up with the new software, right? And then depending on the device, you perform some sanity checks to see if it's come up well. If yes, you commit it. So all that would be taken care of by the device manager. So we are leaving out those details, right, to the device manager. So from the higher level API, either the activation succeeded or it failed.
But if it does not come up with a new software, and it cannot connect to the device manager anymore, for example, then device manager cannot do anything. So, I mean, perhaps the device has implemented something to fall back to the old image after some unsuccessful reboots, but a commit stage would help you. So you could just try out the image, and if everything looks fine, you could commit it, and this would then become the active image from the time.
Okay, I get your point, right? So basically what we had thought was that we still have the commit. It's not that we don't have a commit, but it's absorbed within the device manager, right? And that that functionality is not coming up to the user, right? But as you are saying that.
Okay, I see. Okay, I got your point. So you mean, okay, so it could still be as an operation with a commit towards the device, but this is hidden inside the device manager.
Yes, because it depends on the device, right? So what kind of mechanism they are using to activate the image.
So when I call activate image and that image goes down to the hardware and that image fails on the hardware, is my call to activate image now essentially blocked until that hardware tries to reboot the new image, fails to reboot the new image, goes through some timeout period, goes back and reboots the reverts back to the known good image and reboots a second time?
Yeah,
Is
so
my active image, is that call supposed to be hung until that happens?
No, yeah, so what we are returning is a stream, so you need to be waiting on the stream.
Okay. So presumably then if the hardware reverts because of the failed image, eventually on that stream, I'll get some notification.
Yeah. That's the idea. Yeah.
Okay, thank you.
Yeah, so I think that's it at a high level for the RPCs. Yeah, and definitely there would be many more minute level comments, right?
Yeah.
And
So thanks, Amit. Thanks a lot. This is a great introduction. So can I take back my presentation?
yeah, sure. Yeah.
Can you guys see my screen?
Yes.
Seeing, okay, perfect. So the next steps, as I was mentioning before, is that I will create an API, a repository under OpenCord in Gerrit and mirrored in GitHub, which I'm proposing to call device-management-interface. With these set of people that have capability to +2 merge, plus the TST. Sorry, I forgot to mention that. Well, Suraf and Amit already in the team, plus TST. So David, you're on, and Mahir is also on. That have +2 merge capability on that repo. I will also set up the make files for building the protos, check styles, and stuff like that. As soon as that repo is up, which I expect it to be probably Monday, I will, Amit, please do update. I will send out an email. Please, Amit, do upload a patch on Gerrit under that repo with the protos that you shared today. And then I expect everybody to comment on them. Again, for the things that are included in these protos. For things that are not included and new APIs, new elements that you guys would like to see, I would rather create Jira tickets and we can discuss them in the call or in the Slack channel, or directly patches, and that's a great idea to show how you would like to do it or how would you like to augment them. And then again, we can discuss them on the Slack channel here, and then we can go ahead and merge them or drop them if this proposal is not good enough. Any questions?
So there's already a repo called device management, I think, with some of the Redfish stuff committed to that. How are we going to transition that to a new name specific to a protocol implementation? How do you see that working out? That's a good question. I not really thought of that. I mean, I would like to keep it separate from there, and that's why I added the interface in there. Yeah, I agree it should be separate, but it's a little, confusing with device management. Either, I guess, the code in the current device management repo may need to be able to moved, or maybe that repo needs some sort of indicator that it is a implementation specific or protocol specific implementation of the generic interface. Something I think needs to be done. I'm not sure what either, but yeah, I can definitely at least add in the README saying something like, this is an implementation based on Redfish, and it is not the new API that we're talking on in the Brigade, and that is located there. Right, but I think there's going to be some patterns, right? So there's a Redfish implementation of this interface. There's a, I don't care, SNMP implementation of this interface, right? There's a Yang implementation of this interface. I would expect to see repos following some sort of pattern, so that I understand the repos are related. Yeah. I don't know what the right scheme is yet, but that needs to be considered, I guess. Renaming a repo is always a problem, but yeah, I'll think about it. I'll give it some thought, yeah. And I'll come back with a proposal. I'll hear from the ONF folks too and see what. Yep. Okay, so before we drop, we still have 2 minutes, and I'd like Manuel Paul from DT to give us an initial thoughts on the set of events and metrics that need to be first considered, meaning that really the basic ones that we care about for an initial implementation that somebody cares about, and the tests that we need to write for the initial one. So Manu,
thanks, Andrea. Yeah, can you hear me?
Yes, perfectly fine.
Yeah, so I tried to fill them in, or at least append to your list here online, so people should see that just right under the text you're typing, events and metrics. So proposal is for basically 3 events to cover or consider these as first priority: this fan failure, temperature threshold, and a power supply failure. So for the metrics, I just filled a few in here. I think these are all the device hardware related ones, as said. And yeah, I don't know if we have time now to discuss this list, but if you have any comments or views, I'm happy to answer questions now or take them at the next meeting or over email.
Thanks for putting them in, Manuel. It's appreciated. What I do is, given we are basically at the top of the hour, I'll leave them here. If anybody has any questions, any comments, they can put them in the agenda here, or we can discuss them more deeply next time, knowing the fact that we gave it very little time today. But it was good to put them here as a base and to let people see them. So if anybody has any comments, please do send them over on the Slack channel, via email to me, Manuel, whoever, or comment on the document and we can take it over. Manuel, do you mind if we move this to next time? I guess this is just a piece of whatever the proto is, right?
Yes, I think that is also the comment I was missing to make. I think on these events and metrics, as well as the software image upgrade, we try to facilitate and put it into the proto already. So I work with Amit basically, and I think Amit has probably also already looked at all of these, and they should be in the proto. So looking at the proto should give you the current state of the proposal all together with the list here.
Okay, sounds good. Thanks. But these are the ones that you really care about for a first initial test of whatever the API, whatever implements the API, right?
Yeah.
Okay.
I would think so. So yeah.
Okay, perfect. Okay, then we'll meet again next Friday, and I will roll these over to next Friday and make sure to leave enough time for comments and discussions upon the API. I encourage everybody, as soon as Amit uploads it, to get it. I'll share it via an email, but please do take a look, put any comments there. And we have the wonderful dashboard that Zach put together for us, and the Epic. So if you have any thoughts, anything that you would like to add to the API, please add it in there. Any last comments? No? Then thanks everybody for joining the first meeting. I'll see you again next Friday. I'll try to remember and send an email a little bit before what I did now, but sorry for that. Same time, 8 a.m. Pacific, 5 p.m. Central European. Thanks, everybody. Take care. Bye-bye.
Thanks, everyone. Thanks for your time.
Thank you.
Thanks, Andrea. Thanks all.
Thanks all. Cheers. Bye.
Thanks. Bye-bye.